A famous physicist by the name of G.S. Ohm discovered the relationship between current, voltage, and resistance. He formulated a law that came to be known as Ohm's law. In this animation, we will verify Ohm's law experimentally. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided that the physical conditions and the temperature of the conductor remain unchanged. This means that the current I is directly proportional to the applied voltage V. Alternatively, V upon I is constant. Let us now verify Ohm's law experimentally. We have a resistance box, an ammeter, and a power source connected in series. You can vary the resistance and the voltage and observe the ammeter reading to know how much current is flowing through the circuit. Your observations can be tabulated in the given table. Ready to begin the experiment? Let's begin. For the first part of our experiment, we'll keep the resistance constant at 100 ohms. Click on the 100 ohm key to set the resistance at 100 ohms. Now, we'll vary the voltage and note the corresponding current. Select and click on any of the highlighted voltage buttons in the table and observe the corresponding ammeter reading. The readings will be populated in the table.
When we are having this voltage of 3, then this ammeter, milliammeter, which is to the right side, it is showing there 30 ampere. So check over there on the power source. We have this voltage. It is now 6 volt we are going to apply. So when 6 volts, so milliammeter will show 60 ampere milliampere of the current. And now we are going to change this one to 9 volt. Now it is 90 milliampere current shown. Now next over there 12 volt. So current is of.
Let's increase the resistance and see how the current varies with the voltage. But first, let's replace the 100 ohm key. Click on the 200 ohm key to set the resistance at 200 ohms.
Now over here we are choosing this resistance to 100 ohm.
Let's vary the voltage again and note the corresponding current. Select any of the highlighted voltage buttons in the table and observe the corresponding ammeter reading. The readings will be populated in the table.
So over here when we are taking over here 1.5 volt. So that time current in the milliammeter it is 7.50, and on the power source if we change it to 3 volt, that wire has changed on power source to 3 volt, so this time current is 15 ampere milliampere. And when we change to this 6 volt, then the current in the milliammeter it is 30 milliampere. And when we change to this 9 volt, then it becomes 45 milliampere. Now we have over there voltage of 12.
Now that we have obtained the values for current and voltage for two different resistances, let's plot a graph for these values. Click on the plot graph button to observe how the current varies with the voltage for the 100 ohm resistance. graph shows that when the applied voltage is increased twofold, the current through the circuit also increases twofold. Now, let's see how the current varies with the voltage for the 200 ohm resistance. Click on the plot graph button again. The graph shows that when the resistance is doubled, the current is halved for the same voltage. You can also see that when the applied voltage for the 200 ohm resistance is increased twofold, the current through the circuit also increases twofold. When the applied voltage is increased threefold, the current through the circuit also increases threefold. Let's calculate the ratio of the voltage to the current for each of the resistances. You can see from the table that the ratio is constant. We can therefore generalize that the ratio of voltage to current is always constant for a given resistance. We have thus verified Ohm's law.
Okay, so this is that experiment which we are using for the verification of Ohm's law. What we are known over there, for the verification of Ohm's law, the condition must be verified. Condition means the temperature must be remained constant, and over there the dimensions of that wire should not to change. Okay, so for these two things we are going to turn off the circuit time to time. After taking the reading, we are going to turn off the circuit so that the current will not flow for a longer time, and heat will not produce in it, and thus we are going to maintain the temperature of the wire. So thank you for watching this video.